let me begin the last class. It's often said one leaves the best to the last, and so I've been able to scrounge up a very talented guest speaker. His name is John Blair. John is someone that I've known for 15 to 20 years now and worked alongside on client engagements. But he has an illustrative history as a CEO of a Silicon Valley software firm. He's been an entrepreneur, he's been a consultant, he's been a manager. He has an MBA from Stanford, and I believe he got a PhD from the University of Wallamadoo in economics. So he's very, very well credentialed. But today, we're really going to draw on his deep understanding of software. And he's fond of reminding me, since his background is in computer science, that software is going to run the world. There's not much room for the rest of us. And certainly it's the case that software is incredibly important in all of the industries of the future. And hardware is becoming less and less important. And so I feel we all need to be alert to this long-term secular development. Kind of the new Moore's law is what's going on in AI and in software. John may even tell us it's more amplified than Moore's law was in hardware. So without more, let me hand it over to John. He's a little bit familiar with the Dynamic Capabilities Framework, and in fact has co-authored a paper with myself and Charles Baden Fuller from Cass Business School in the UK. And he bridges the world of ideas and the world of practice. So without more, John, the floor is yours.
David, thank you very much. That's a very kind introduction. Let me see if we can make the software technology work, and you can share, and we can share my screen, which would be exciting. Look at that. All right.
And actually, John, could you enable, now we're seeing notes view. Can you enable presentation view?
Let's try swapping the displays. See whether that works. Oh, good. Okay. Okay. All right. So we want to swap displays, but we want to that is a trick. I don't know how we make that work, because as soon as I go into so you guys are getting notes view. Is that what you're getting?
Correct.
Terrific.
Yeah.
Great. Okay, so let's do this. Let us stop sharing. And right, then let us share a screen. And how about that?
Looks good.
Perfect. Yes. Good.
All right. Okay, that's a miracle. It's a triumph of something over Microsoft. Right. Okay, so as David said, what I'd like to do is take you all through a very brief, very incomplete, very high level set of descriptions about what we think is going on in passenger mobility and the various forces of disruption that our analysis suggests are coming down the pike. And in this, what I've tried to do is be a little bit more assertive than I would normally be, and a little less guarded. And since all of this work is ongoing and provisional, it's as much as anything to get the conversation going and suggesting where our analysis might be wrong and where it might be right. So let's start with let's go with that. The overall setup, as David has suggested, is that my analysis suggests that by the end of the decade, commercial and passenger vehicles are going to be defined by their user experience software platform. That is going to be the fundamental driver to competitive differentiation. And that changes things. That fundamentally changes the competitive environment in the automobile OEM sector. What I'm going to do here is I'm going to focus just on passenger vehicles, not for any reason other than in order to keep the conversation somewhat bounded. But the same kind of effects occur in other areas, but we'll stay pretty much focused on passenger vehicles for the purpose of this. I wanted to start with a quote from one of those rare New Zealanders that is famous for something other than sheep farming, which is Sir Ernest Rutherford, who said there's only physics. Everything else is stamp collecting. And my view of this is there's only software. Everything else is infrastructure. And let me see if I can justify this somewhat heroic view to you guys as we roll down the track here. In order to do that, what I'm going to do is, as I said, in a very brief and perhaps over a general way, and perhaps over assertive way, I'm going to hit on three particular areas. We're going to look, first of all, at the technology, some of the key things that are happening in the user experience area and in autonomy. Then look at the economics, and I'm focusing there on two particular areas, what's going on in powertrains and what's going on in platforms. And then finally move to the strategy area about where disruption might come from and how to fit all of this into a dynamic capabilities framework. So that's the setup. And starting off with user experience. If we look at what's happened over the last 20 years, software now manages and controls almost all key vehicle systems. Climate, media, advanced driver assistance systems, the engines, steering, transmission, brakes. All of these things have very, very high levels of software involvement in them. Controllers, direct braking systems, all of these things are massively software dependent. And what we're seeing at this point is that now software is a very material part of the overall cost of the vehicle in terms of the fixed costs that are required to be able to maintain it. And electronics in general are a very large and increasing set of important components in those vehicles. So we've seen over the last 20 years, nothing new. Software becomes increasingly important in motor vehicles. The challenge is that the user experience is close to pitiful. So you may remember this ad from about 5 years ago, which was when a PC was being upgraded to have a webcam attached by use of insulation tape and something stuck on the top of his head. What we're seeing at the moment, if you've ever had the misfortune to use something like CarPlay or Android Auto, these things are god-awful. And they're really awful for the most fundamental reason that they are not integrated in any way. in exactly the same way that the webcam was belted onto the top of John Hodgman's head. So what we are seeing is these software user interfaces that are stuck onto a screen and completely separate from the rest of the vehicle. And that's the problem. That's the worry. If you roll a truck forward, what will happen is that by the time we get down the track 10 years, our projection is that network software is going to define the entire user experience. What you're going to get are integrated software systems that pull together all of the critical vehicle systems. These things are going to be globally interconnected over wireless networks as we move from 3G to 4G to 5G. The fact that they're now continually interconnected means that they can be continually upgraded. The systems can be continually improved over the lifetime of the vehicle. And finally, and in my view, most crucially, they're going to be surfaced to the driver as an integrated software display and control system. Everything pulled together in a unified user experience and user interface. And that's a transformative change, because we've not seen that kind of integrated experience in a software sense up until now. But the question then is, okay, what are the strategic implications of that as it rolls forward? So that's the user experience challenge.
John, before you move on, you say integrated software display, and of course, you want everything to be integrated. But I'm reminded of the quote we had from Tim Cook that companies have a lot of problems integrating things, and that one of the things that Apple does well is integrating, I assume they meant software and hardware. But is this integration something that is easy, or is it something that is hard? Does it become the key defining capabilities of companies in the future, or does the software itself figure out how to integrate?
It's hard, but most crucially, David, the question is whether or not it's horizontal or OEM proprietary. And we'll get into this a little bit further down the track. But the question is whether or not, if you are an individual OEM, whether or not you can produce a system like this, or whether or not you are continually trapped in the model with John Hodgman and the webcam on his head, where I've got two user interfaces that are essentially continually fighting for dominance and fighting for control. So I would say it's hard, and it is naturally horizontal, are the two things, but we'll talk about the latter of that a little bit further on.
Hey, John. This is Dan Andrews. So I'm looking at this, and it's a pretty immersive display that you have pictured here. And the first thing I think of is I don't want to be driving and looking at this at the same time. So is this kind of coordinated with the autonomous vehicles as well, and they kind of play off each other? Because if I'm inside the vehicle and I don't have to worry about driving, then I want this. But if I'm driving, I don't think you want me watching this.
No, you don't. And this one of the joys of a soft display is that it can be completely integrated with driving circumstance. So that what you would expect this kind of display to be is when the vehicle is under some form of autonomous control, and we'll talk about autonomy in a second.
Okay.
But when it is under your control, then it should be, and probably will be, a much more typical software controlled instrument panel that is reminiscent of the ones that we have now. So it will be these, because it's soft, all of these systems can be far more context aware than they are at the moment. But I completely agree with you. If you were driving a car, you don't want a picture of your Auntie Mamie and your Uncle Bob up in front of you. You want to know what the engine is doing, what the car is doing, what the nav is doing.
Now, this is interesting because I mean, what the first thing that comes to my mind, I'm a stock speculator. It's like, whose software is this? Because someone's going to own this, and I want to invest in that company. They're going to have a head start, right? I mean, that's the first thing that goes in my mind as soon as I see this, right?
Right. Well, and we'll get to this as David has unkindly pointed out. My level of economics is not as deep as anybody in this course. But nonetheless, the thing that I would like to talk about is where the bottleneck assets are. And the display technology itself, in my view, is going to be largely commodity. These things are hard to build, but there are a lot of things that are hard to build. The display technology itself is going to be one of those things that can be readily outsourced, and will probably not be a source of strategic advantage. But there are other areas that will be, and that's where things get interesting. Okay, let's roll on to autonomy. Go from there. I'm going to stay in two areas of autonomy. I'm going to ignore the levels below level 3, and I'm going to ignore the levels above level 4. And we can talk about why and the rest of it. But for the purposes of my discussion here, let's look at those two levels. Level 3 is defined by the SAE as sustained autonomous vehicle capability within a domain with the expectation that the driver will respond appropriately to requests to intervene. So level 3 assumes that you have a driver, almost certainly an in-vehicle driver, who is capable and situated to be able to respond appropriately. Now, the word appropriately is doing a lot of work here, because we don't know how long you are given in order to be able to be forced to take control. There has to be some reasonable handoff interval, and there has to be the expectation that the driver in the driver's seat is able to look up from Harry Potter or whatever it is that he's watching on his other screen, figure out within 0.78 of a second what's caused the AV system to panic, and then take control of the vehicle and successfully guide it away from whatever caused it wrong. But let's assume that all works happily. Level 4 is the next level up, and that is sort of sustained autonomous vehicle operation within a domain with no expectation that a driver would respond to a request to intervene. So what we're talking about here with level 4 is the kind of level that's required for mobility as a service without a driver. This is the area where Uber can drop the driver out and start to get all of the economic benefits that are supposed to evolve from that. So level 3 and level 4 are the two areas that are of most interest here. Level 3, I'm going to define as an advanced driver assistance system. This is something that is useful even if I am a driver, in the sense that I can, for example, navigate the car to a freeway, and the car will be able then to happily drive me on that freeway until I get to the office, and then I can take over. That's useful to me as a driver. It's a value-added feature for a motor vehicle. Level 4 is what you need for mass mobility as a service. Okay, within a domain. Within a domain is where we really have to focus in order to make the economics work. So let's define a domain. What we're talking about is some geographically or otherwise defined area within which the AV system can operate. And it can be arbitrarily broad, or it can be arbitrarily narrow. I have here a partial picture of what a geographic domain looks like. But there are, of course, other areas. The domain can be that it needs to be daytime, or it can be that there is no snow, or that there is no rain. The domain can be defined under whatever set of constraints that you want. So both level 3 and level 4 per se aren't particularly useful until we define what the domain is. And we'll return to this in a few minutes. But what we need to start thinking about is for level 4, for mass, that domain has to be sufficiently broad that the economics make sense. And that's where life gets interesting. So the good news as far as AV is concerned, machine learning systems, which are deep learning systems, machine learning in the broader sense, continue to make, as I think we all know, pretty remarkable progress in pattern recognition and rules-based systems. These things are getting really, really good at being able to pass photographs, to be able to play chess, to be able to play Go, to be able to work in a very efficient way in areas where there are well-defined rules and well-defined environments. So that's the good news, though perhaps there are some somewhat worrying exceptions to these things. And what I've got here are, these are current systems that are designed to detect traffic signs. And you can spoof them really pretty easily by changing the KFC logo just slightly as above. The system happily recognizes it as a stop sign. If you change the Texaco sign just this little bit, as you can see the slightly gray, red areas, the system happily recognizes it as a do not overtake sign. And the reason for that is that machine learning systems do not fail gracefully. They fail catastrophically. And the reason for that is the way that they work, in that they are systems that are trained on increasingly large data sets, but there's no underlying algorithm, no underlying system that enables you to iterate towards a level of uncertainty. If the thing gets confused, they tend to get real confused real fast. And the inability to distinguish a KFC sign from a stop sign is something that one might consider material to an autonomous driving system if one wasn't being charitable about it all. The bad news. The bad news is that while machine learning systems, as I said, are making remarkable progress in rules-based systems, real-world traffic systems aren't rules-based. That's the problem. Traffic rules are not rules. They're ill-defined, they're incomplete, and to quote Hamlet, they're more often honored in the breach. It's an interesting experiment when you are driving. If you're driving in any kind of reasonably dense area, just look and make a note to yourself every time you do something that is technically illegal, but which needs to be done because of the circumstances of the traffic that you are in. Because the truck is double parked, you go around double yellow lines. Because somebody is blocking an intersection, you reverse out of a one-way street. But these sorts of things we do all the time, and we need to do them. But the implication of that is that what we call traffic rules are not rules. They're guidance. They're general guidance. And so the fact that machine learning systems continue to make remarkable progress in pattern recognition and rules-based systems does not help you in that kind of environment. So this is a picture of the Arc de Triomphe. And you look at this, humans can deal with this. We can happily deal with this because we sort of know what's going on. But an AI system, not so much. Okay, so first hardcore claim that I would like to make well in advance of the facts. as far as I know, there is no technology path to level 4 AV outside of very limited, very simplified traffic domains. You can do it in Phoenix. You can do it in Phoenix as long as it's not snowing, as long as nobody's not working on the roads, as long as the traffic lights are working, things like that. It's all good. You're able to do that. So that's what I mean by limited, simplified traffic domains. And by no known technology path, I really do mean that. We are, except as software engineers, as hardware engineers, we are really good at being able to evolve systems down a known path and to be able to meet a known set of performance goals and criteria. The challenge with level 4 AV outside the kind of simplified traffic domains that I went through is that we don't know what those criteria are. We don't know what those goals are.
Well, John, just may I stop you there for a moment? Because earlier on you said that software is going to run the world and everything else is infrastructure. Do you now have to modify that that claim based on what you're saying here?
No, not at all. I'm just saying that we need to, when looking at the strategic questions that are coming up in the automotive industry, we have to be technically real. And there is an enormous amount that these systems can do. For example, as I mentioned before, level 3 AV, where there is the expectation that there is a driver, can be extraordinarily useful for you or me. It can be a very valuable, value-added feature for a passenger vehicle. I would love to be able to, back in the day when I was living in California, to be able to put my car onto 101 North and have it drive me to Emeryville, and then get off, then have it pull me off the exit ramp, and then I can basically take it from there. That is a doable problem. We know how to do that. The reason that I'm making this claim here, as strongly as I am, is that an enormous amount of the mythology, what I would characterize as mythology around the revolution that's going to happen from mobility as a service and the elimination of the driver, is based, I would argue, on technical fantasy. We don't know how to build it.
All right. So this ties in with dynamic capabilities around sensing and sense making, and the sensing part is okay. The AI can really play a role here, but the sense making part is when and how soon, and I think what you're saying is that, and at what cost, right? That
Yeah.
the sensing part is a lot easier than the sense making part. Is that a conclusion of what you've just articulated here?
Yeah, I mean, what we're talking about here, I'm going to use your dynamic capabilities framework, David, and here we are in the sensing area, really just understanding what's going on out there and what's technically realistic. And then the next step after that is to be able to figure out, okay, what are the implications of that? So within the limited time that we have here, I wanted to sort of give a sketch across the various areas that are important. But this is understanding what the limits are to these kind of systems is, I think, an extraordinarily important part of any kind of sensing arrangement.
Maybe just one comment on this one, Karim speaking, and it's really acknowledging what you're saying here, John, is Aurora. You mentioned their CEO here, and part of the strategy to deploy this autonomous technology is to start with a truck, because as you said, John, it's simpler. The pattern is more stable, and from a strategic perspective, truck is first on the highways, and Aurora is putting efforts now to accelerate to have first truck autonomous.
Yeah, no, that's exactly right, Karim. And I would argue that Aurora has done that because underneath the covers, they've realized that passenger vehicles won't work. And now you have a reasonable shot that you can make trucks work, but it's not because they're trucks. It's because they're on freeways.
Exactly.
You can instrument the freeway.
Absolutely.
And I can make the problem technically trivial by putting sufficient infrastructure onto the freeways. If I can map them precisely, then the vision system doesn't need to be the sole arbiter of where the road is. If I can put in electronic signs instead of visible signs, then I can do the right thing with respect to being able to signal to the trucks. I can do things with the cops, with fire, all the rest of it, so that an AV system can do the right thing in the event of emergency. I can do it within it, and this returns us to the limited domain. And so one of the reasons that I wanted to stay focused on passenger vehicles is for exactly this reason, that there are absolutely use cases outside, and long haul trucking is, I think, one of the most interesting, and the economics there are very different, as you point out. Okay, so I'm arguing that the problem with AV is that it only works in limited domains. Well, maybe those limited domains make sense. Maybe the whole thing works as far as mass is concerned. So one of the things we looked at is where does Uber make its money? And if you look at Uber in the New York market, which is their most valuable market, then by a significant portion, the largest amount of money is made out of Manhattan. And as you can see, the rules aren't in Manhattan. So this is, with the probable exception of Taipei and perhaps Calcutta, this is a nightmare for an AV system. It has no idea how to be able to handle this. So again, to return to David's question, the reason I'd like to highlight this is not because autonomous vehicle technology does not work at all, but that the technical limitations of how the systems work and how they work in the foreseeable future is one of the most important parameters if you're an OEM trying to figure out where you go from here. Okay, that's a brief view of the economics. Of the technology. Let's move on to the economics. And again, apologize for the high level version of this, but I wanted to give you guys a sort of an overall picture of many of the things that are happening. This is a picture of the different fuel types, the three fuel types that are most likely where we're heading. And this is a two-dimensional chart. The horizontal axis is the gravimetric density, and that's basically how much energy you can put into a kilogram. So obviously, the more you are over to the right, the more energy I can have per kilogram of weight. The vertical axis is the volumetric density. So that's how much energy you can put into a liter. So those two things are the key parameters if you're looking at the efficiency of different fuel types. And if we look here, so here's gasoline. Where you would love to be, obviously, is up here, up in the top right-hand corner. Very high volumetric density and very high gravimetric density. What you see is the gasoline has high volumetric density and reasonable gravimetric density. Here's hydrogen. So the adjustment here is for current, fuel cell, and when we get to Lion in a second, battery energy conversion deficiencies. So you can imagine that we will be able to move from where we are here now with this orange dot towards this orange dot. So what this tells us is that hydrogen is potentially significantly better than gasoline in terms of the amount of energy I can put into it at unit weight, but not nearly as good as gasoline in terms of how much I can put in terms of unit volume. So an interesting comparison between them.
What's the green dot? Oh, there we are.
The green dot is this, lithium. So these are line batteries. And again, I used the word pitiful before, but the word pitiful does come to mind again. These things are simply not very good along either spectrum. Now, what this says to you is that you have to be extremely careful in looking at these new fuel sources, and in particular, what kind of trajectory we're likely to see over the foreseeable future that will drive penetration of these different fuel sources into the marketplace. But what you see here too is the reason that it is so hard for lithium to be able to handle high density heavyweight trucking. Hydrogen is where you would like to be able to be as far as heavyweight trucking goes because of its significantly better gravimetric density. In passenger vehicles, gravimetric density doesn't matter nearly so much, and so it's difficult to see where the advantage of hydrogen is in that area. So this is the way the world works today. That's the fundamental, if you like, physics of the problem. Let's look at some of the economics of the problem. So these are cost trends in proton exchange membrane fuel cells. These are the key technology for hydrogen fuel cells that are out there at the moment. And what you see is that from 26 to 2010, we had a reasonably rapid fall, 17% per year in the cost of dollars per kilowatt. But since then, 2010 to 2016, the rate of fall has been significantly less, around 2% per year. And the projections from the people that understand these things is that the rate of fall is going to continue to be reasonably modest. So we're not going to see much, at least barring a miracle, which is always possible. We're not going to see a dramatic improvement of the cost of fuel cells as we roll forward for the next 5 years or so.
John, just stop there for a moment. Go back, please. Maybe that's a Tesla effect that, remember up till about 2010, everyone thought that hydrogen was the fuel of the future. And then along comes Elon Musk and shows you can squeeze more out of lithium ion than anybody thought. And so the whole industry goes off on a different trajectory. And maybe it's just demand driven. You're treating this like it's a Moore's law with an unexplained kink. But perhaps that's not the case. And perhaps this is just a demand side consideration that has reduced the amount of R&D effort that's gone into it.
That could be, David. I mean, there's a well understood saying in physics that revolutions in physics never happen until the old guard dies off. And
yes,
the argument has been that a lot of the interest in hydrogen up through 2010 was driven by the old guard, and that they're starting to die off. And so as a consequence, the amount of focus on fuel cells has been reduced. That being said, these numbers here are to a pretty fair extent driven by the known science, in that anything that would cause them to dramatically change would have to be a fundamental shift in the way that fuel cells are built, which is absolutely something that could be done. It's just something that we don't have on the horizon at this point. That being said, your point about the Tesla effect is I think absolutely well taken. And if you look at the next slide, what you see is perhaps the exact example of that, which is that up until 2014, falling at 16% per year, prices per kilowatt hour. Through 2018, it was falling at 26% per year, a really dramatic effect, which was driven by scale and continued improvements in engineering, just really dramatic impact on the cost of these systems. Now, the projections here are not meant to indicate that the rate will suddenly slow down to 7.8% per year. What I'm saying here is that all you need in order to get to $100 per kilowatt hour, which has always been the defined point at which line powertrains are competitive with internal combustion engine, you only need to fall at 7.8% per year to get to $100 per kilowatt hour. So if cost improvements continue at anything like the rate that we've been seeing, then we are going to get to a critical cost factor well within the next 5 years. So what does that mean? In 2019. This is the cost gap between internal combustion vehicles and battery electric vehicles, lion-driven vehicles, measured in $1,000, and it was $12K in 2019. And the projections are, again, no science, no miracles required, but basically driving everything along, improvements that we know how to do. That we will eliminate that cost gap between IC vehicles and battery electric vehicles by 2025, and that if anything, the battery electric vehicles will be somewhat cheaper on an absolute value basis. So that looks good.
That's assuming lithium ion is the battery source.
Yeah.
And what about the rare earth issues and the supply of lithium? I mean, look, John, squeeze this into our dynamic capabilities framework. Let's suppose you're the CEO of Honda or Toyota or General Motors or Hyundai, and you've got these choices. And one of our students said, David Southern, who you can see as a CFO. What do you walk into the CFO's office with in terms of a decision criteria for what you're going to spend money on? Are you going to do hydrogen, or are you going to do batteries? Are you going to drop the hydrogen cars? I mean, bring all of this into the executive suite for us, John, in terms of how it affects the seizing part of dynamic capabilities. Maybe that's where you're going.
That's where I'm going. Yeah. What I wanted to do, David, was give you all the overall landscape on the sensing side about what's happening, what's projecting to be happening, and then fold it into the sense making and the scenario building side of the whole thing. So hopefully we'll get that. If we don't, you can remonstrate with me then. Okay, so this looks good. Here's the challenge. And this is these are the current numbers for the comparison of life cycle emissions between the different technologies. So on the left, what we have is a gasoline internal combustion vehicle. I don't know why I called it an ICE EV. It should be just ICV. The next one is a gasoline hybrid electric vehicle. The next one is a hydrogen fuel cell electric vehicle. The next one is a battery electric vehicle with a 70 kilowatt hour battery pack. And then finally, the last one is a battery electric vehicle with a 200 kilowatt hour battery pack. So what you see, sadly, is that the difference between a gasoline vehicle and a battery electric vehicle in terms of total emission is not all that great at the moment. It's what might be optimistically viewed as small. Now, maybe things can get better. You know, I'm sure that they can. What you see is the different things that characterize it. But what's driving the big blue lines for H2 and battery electric here is this next problem. And this is the next problem.
So sorry, John, back to that last set of bar charts. Are you saying that there is no difference in the total life cycle emissions between battery vehicles and gasoline vehicles this is today or in the future?
This is today.
Oh, today. Okay.
Yeah.
All right.
But let's see why. Yeah.
All right.
So let me explain why. And the reason why is this. So what you see is the US energy grid, how we make energy. And the challenge is, if we continue to make energy using fossil fuels, which we are at the moment, and if you can discern a trend towards increased renewables, you're better. Well, you're an economist. I'm sure you're able to see a trend in these data that I'm not able to see. But the problem is that if we can't move the grid to renewable, then the whole thing is a complete waste of time.
Right.
And the reason I bring this up is not to be mean, or not just to be mean. I enjoy being mean. It is that if you are the CEO of a company that is looking at these kind of problems, to your point earlier, David, this is an ecosystem question. This is where you have to consider part of the ecosystem if what you're trying to do is address climate change. Where the power comes from is a crucial part of the EV ecosystem. You can't just ignore it. Otherwise, it's simply a branding opportunity. Okay, platforms. This is a very high level picture of the two systems that I want to differentiate between for you. On the left-hand side, we have what I'm calling advanced active safety. And this is basically the don't hit anything system. This is the thing that should avoid you skidding off the road, that should avoid you running into the rear of somebody, running a red light, all of these kind of things. Active safety as differentiated from passive safety, which is don't kill me after I have hit something. And these are the major elements of the advanced active safety system. On the other side, what we have are the major elements of what I'm calling advanced driver assistance, which is the system that evolves into level 3 and level 4 autonomous driving. These are the systems that enable you to be able to synthesize the environment, figure out where the car needs to go, and be able to get it from A to B with the right level of safety and efficiency. They're combined together in terms of the drive control and in terms of the cockpit, and they both extensively use vehicle to infrastructure and vehicle to vehicle communications in order to be able to work. So these two systems extensively overlap. And I think an open technical question as to whether you can build one without the other, or whether it is really exactly the same system. And that's one of the things that we'll talk about in a little bit. The key point I want to make is that advanced driver assistance is not a component technology. It's a distributed services platform. And what I mean by distributed services is that the system itself has to combine together processing and data locally in the vehicle, locally on the cloud, and remotely on the cloud. All of the systems have to be tied together. All of them have to be integrated together. You cannot build these things without this kind of integration between the different levels. And that's what I'm referring to as a distributed services platform, a DSP. And the thing is, we know about digital service platform economics because we've seen them before. And they differ profoundly from the traditional component software technologies that are used in automobiles. DSP systems are rented, not sold. They deliver just extraordinary returns to scale. And they demand very, very high levels of research and development. Those three characteristics, rented, not sold, returns to scale, and a high R&D, mean that they, in our experience, inevitably devolve to ecosystem duopolies. And we talk a little bit about whether or not those are regional duopolies or maybe triopolies, to give myself a little bit of cover. But we can look at what happened in the mobile phone industry, which I think is relevant here because the competitive dynamics are similar. The red rectangle that we have here shows what happened when the iPhone hit. And we went from a system where we had component technologies, Microsoft, BlackBerry, Palm, Symbian, within 3 years, essentially gone. And now what we have is a duopoly of Android and iOS. And the reason that we have a duopoly is essentially the same reason that we had a duopoly in PC operating systems in the 1980s. It's because the economics force you to do one. And wherever we've seen companies try and break out of those duopolies, the result has been very, very minor market success.
So John, as you know, Huawei has, I think, announced that it's going to try and break loose from Android. So if your theory is correct, if they succeed, then Android has to fail or Apple has to fail if it's only two, or can you, I mean, that's if they're separate markets, if China goes one way and the rest of the world goes another, certainly China is a big enough market to support a Huawei standard, I would think.
Yeah. I mean, Roadway is an interesting example, right? Because it brings up two separate things: whether or not there can be regional differences, and whether or not you can establish a new system. What Huawei is doing at the moment is Android. They're just doing Android without Google. So it is exactly the Android operating system underneath. Android, as you know, is open source, and there's no barriers to Huawei being able to take that. What they've lost is access to all of Google apps. And the questions we'll get to in a little bit is whether or not that's viable or not. What they're not doing is attempting to do another new operating system in mobile phones from scratch, because I think they recognize that it's not possible. But, perhaps they'll have a shot at it. I don't think the economics would allow them to succeed.
So what's the lesson from this, John? Why I still don't understand why it's only 2 or 3. Is it just is it network effects or scale effects or what is it?
It's what we would call network effects, but also its close cousin, ecosystem effects. The problem is that in order to establish a platform inside, and we're inside mobile phones for the moment, but let's take it back to automobiles in just a second. In mobile phones, in order to establish a platform, you need to be able to have all of the apps on that platform that are required to give it critical mass. And the the economics of software development by independent software vendors is they can afford to do maybe two. They
I
can't.
see. Unless
And
they're close. Unless they're close. You can't reuse. If you got to completely redo an app, if you're going to do it on iOS versus Android, I thought it would be a lot easier if you'd done it for one. It would be 20% extra to do it for the other, but it's not.
It varies, but you've got the entire user experience side of the app has to be native, and there's enough differences between it. Now, if we are building the David Teece sheep monitoring software, then you can happily build that in a cross-platform environment and it'll work. That'll be fine, because there's probably only the population of New Zealand using it, and so we don't worry if it's not entirely native. But if you're doing something like a hardcore media app or a hardcore communications app, you build the entire UX side of it natively. The underpinnings, the cloud side is the same, but the app itself is fundamental.
Okay.
Okay, let's as David has been constantly prompting me to do, let's bring it into a
Finally getting into strategy. That's good.
Right. Okay. So this was the premise that I promised we started with by the end of the decade, commercial and passenger vehicles are going to be defined by software, and that's going to really screw things up. So let's talk about that. The first thing is the standard take that's out there. The first, that there are three sources of disruption in the industry. The transition to new powertrain technologies is going to potentially disrupt the industry. Mobility as a service is going to decimate retail markets, and autonomy is going to transform mobility as a service. Those are the three big takes that were out there, 2018, 2019, to some extent 2020. My claim, one out of three. The new powertrains is a fundamental important change. Not because they're new powertrains, but because they commoditize the vehicle platforms. To build internal combustion engine vehicles was extraordinarily hard. And it was hard to be able to break into those markets. Electric powertrains much more capable of commoditization than IC powertrains. So important. My argument, for the reasons that we talked about earlier in terms of the technical limitations of autonomous vehicles, and in particular getting level 4, means that mass is likely to sideshow. Sure, it's going to be important, but basically they're going to be relatively traditional cars that those things are buying, and it's basically a taxi service in a party hat that's being funded by venture capitalists. The economics are unclear. It'll work out, but I don't think it's going to be the major impact that perhaps was mooted a couple of years ago. And then finally, autonomy is going to be slow and relatively limited. It's going to be incremental advanced driver assistance, which means that it's going to be a valuable, value-added feature for passenger vehicles. And again, to Corinne's point, we're just in passenger vehicles at the moment, we're not in trucking. But it's not going to fundamentally change the market. Nonetheless, I think that we're heading to a disruption. And the first one is that the DSP duopolies are going to drive to own the user experience. That is, the way that I interact with the car is not going to be driven by the car manufacturer. It's going to be driven by whoever owns that user interface. Commoditization means that we're going to see captive OEMs grow in importance, where essentially the OEM side is outsourced as a tier one provider. And then finally, network software ecosystems become the bottleneck assets. So that's the argument. But there's a hell of a lot of uncertainty. And this is just one of the areas of uncertainty that I thought might be interesting. These are the projections for electric vehicle sales market share. What share of the market EVs are going to reach by 2030? And what you can see is that the most remarkable thing, or the most insightful thing that you can take away from these projections, is that nobody has any idea whatsoever. It's somewhere between 6% and 40%, which is okay, good. I'm not sure how helpful that is.
Well, this is why you need dynamic capabilities. It's managing under deep uncertainties, and here you've got these huge swings in parameters. Wood Mackenzie is a fossil fuel consulting firm, if I remember right. So I'm not surprised they have the lowest estimate.
Oh, David, I'm sure that their other consulting gigs couldn't possibly have any impact on any of these factors. But yeah, I mean, your point about uncertainty is exactly right. And the problem is that this is just fundamental this time. It's not like you can fix it. This always struck me as a funny survey, which was back in 1971. People were asked how likely it is that you buy a video recorder. And they anticipated that 3% were likely to buy such an exotic and strange object. And so, David, as you say, this is, if you are looking for a circumstance where you have massive amounts of uncertainty, then that's the area where dynamic capabilities is designed to address. So what I've been doing so far is hopefully not excessively giving you guys an overall picture of the sensing side, in at least three areas. The next step is to look at the sense-making side of this, and for that, there's a couple of things I want to touch on. And again, David, drawing on some of your previous work, I want to make the point to differentiate between autonomous innovation and systemic innovation. And this
was a question on the exam, John, so I'm sure that you have a high interest from the students at this point. Or delight, should I say, because they all got it pretty much right. So, but they'll be pleased to hear your explanation and your application.
Well, I'm glad I will. And I'm sure you didn't have the fancy orange and green graphics, David, that I'm regaling you with here.
No, I can't match your graphics ever. They're very good.
Okay. But I won't belabor the point because it's familiar to everybody here, which is the paradigmatic example here is a turbocharger. You can shove it onto an engine, and it adds a new element to existing established assets and technologies. Systemic, you've got to do a whole bunch of separate things. You've got to add multiple new elements in order to be able to make the system. And the reason I bring this up is not only to genuflect in the direction of Professor Teece, but also to make the point that what we're talking about here in terms of a soft car is a systemic innovation. That we need to change multiple elements of the ecosystem in order to be able to compete. And let me give you a sense about what I mean here. So this is an evolved, over on the left, I have here is the evolved traditional OEM ecosystem, where the OEM owns the user experience for the parts that it controls. CarPlay or Android Auto or whatever is one of the several Chinese equivalents owns the digital service provider user experience. The two things coexist uneasily against each other. The traditional OEM sits here. The OEM owns the advanced driver assistance systems. I'm sorry, I've reversed these two. I'm sorry, my apologies, it's a new slide. The OEM owns the advanced active safety systems, and the horizontal driver owns the advanced driver assistance systems, and there's a bunch of suppliers underneath. The disruptive ecosystem is fundamentally different. What I have is the digital service provider owns the user experience. So let's make that Apple, just argument's sake. So Apple now owns the entire dash, everything. Underneath Apple is a captive OEM, somebody who basically Foxconn Auto, that makes the car underneath Apple. And underneath it, we have a horizontal advanced driver and advanced active safety system. So what we've done is we have disrupted the way that the car works in a fundamental way because the user experience has been changed. The hardware, in this case, the car, has been abstracted away in exactly the same way that the hardware was extracted away in the mobile phone system previously and in the PC industry before that. So let's look at the possibilities of how that.
When you say abstracted away, that means the software all goes into some foundational level. Is that
what I mean? Is that nobody cares anymore who the captive OEM is. It's just the car. Nobody cares. What sells the car is the user experience, and the user experience is the software. So what I mean by abstracted away is that the underlying hardware inside the car is incidental in the way that it is on an iPhone or on a Samsung phone. What really matters is software.
So this is where the platform becomes a commodity, as you were saying before, correct?
That's right.
But
Exactly.
I don't understand. So you have the evolved OEM ecosystem. Remind me, what is that compared to the disrupted? Is that today on the left and tomorrow on the right?
This would be 2030 in a view where let's make another one. This is Ford. So in 2030, Ford has a new user experience. It has a new soft dash or something like that. It's all whiz bang. And it also runs Apple CarPlay 2030 or Android Auto 2030. And the two things kind of maybe coexist in the way that these systems do today, but they're really fundamentally distinct, and they come from separate providers. So this is Ford 2030. This is Apple 2030.
Okay, so the right that's what the world will look like if new entrants like Apple and Google completely disrupt the old OEM system. So if the OEM incumbents evolve, they get to look like the left hand side, but the new entrants, and maybe including Tesla, is already over on the right. Is that right?
No, not already over on the right. This is what it would look like if the world proceeds down the way that technically it would be able to do, and it seems like it would be advantageous for the DSPs to do. So the question by this, if you are Ford or GM or whomsoever, is okay within a dynamic capabilities framework. What are the competitive dynamics? What are the bottleneck assets? What's the strategic path in this kind of uncertainty? And what do you do if you're Hyundai, for example? So it might be worthwhile looking at some lessons from the mobile phone ecosystem. And the first one to take away is, if you own the user experience, you make all the money. Really, as fundamental as that. The global share of smartphone industry profits in 2015, which is one of the years where we have some data, but perhaps is overstated, but I think gives us an idea.
But let me just stop you here when you talk about the user experience, because Kareem Shablin, one of our Haas alumni, is on the phone, and of course he works for Faurecia. which does the interiors of the car, which is also part of the user experience. You have this view, John, that the user experience is only the eyeballs, but there's bums on seats and things like that. That's part of the user experience too. So does Kareem have to worry that his company is going to become commodified, or is that part of the user experience, and is he part of the surviving key co-specialized asset that's actually a good business to be in, while the rest of the industry is in the toilet?
I guess I'd answer that in two ways. The first one is I'm using user experience because I'm an engineer. I'm using it purely.
No. You can use user experience, but it's not. What I'm suggesting is the user experience, if you're in a car, is not just what's on the screen. It's also the fit and the feel and the comfort
Absolutely.
and the acoustics, and it's beyond what the computer science has mastered.
No, it's absolutely fair, David. And my view here is unreasonably narrow, and you are correct to demonstrate with me in
I
this
know,
area.
just correcting you, John, and hoping that we can create a future for Kareem. Otherwise, you'll have to swap jobs.
In fact, I like the angle that, John, you brought to the discussion on the user experience, because it's if you look at the incremental innovation which happened in the last 20 years, Tesla was really the disruptor, because before that we had in what we call in automotive Kaizen improvements, right? Inside the in-vehicle experience did not change that much. Then Tesla came on board. Tesla came on board with switching the user experience, putting the display at the heart of the in-vehicle experience. And if you look back 8 years ago, nobody in the automotive industry believed that Tesla would make it. That's a fact.
I still don't.
You still don't?
No. I can't figure out how in God's name they still survive. But anyway, that's a different question. Yeah. They're not an automobile company. I think they're some kind of magic company. It's very, very strange.
Yeah, and his magic, and no doubt with capitalization, he's been able to do. But user experience is, I think you've nailed it from this perspective, because my current company, we're equipping one vehicle out of 3 in the world, inside the vehicle, and we've invested a lot for understanding the user experience and developing the right technology, meaning the technology not per se, not the technology for the technology, but which has a purpose, which makes a difference for the end consumer. And this is a shift, because my company was traditionally an engineering company. Will we be fast enough? That's a key question. I don't know.
But absolutely agree with both of you that I'm using UX as a term of art deliberately narrow, but it's only part of the entire value proposition. And it's one where, indeed, I would imagine that to your point, David, the assets would be co-specialized, very much co-specialized, in the same way that if you see in the smartphone industry, which I know I'm constantly leaning on as an example, where the hardware in those systems is absolutely co-specialized with the software.
John, I should also, I'm sure we're aware of this, of course, but when you look at this profit distribution, and indeed this is a class in strategic management, and that's what we focus on, how to build long-term sustainable profits. But the employment effects, I mean, Samsung's getting more jobs out of this than Apple by a long shot. And the other category, which is underwater, is probably supporting hundreds of thousands of jobs too. So needless to say, governments are looking at this through a different lens from what we're looking at. But you're quite right, the money in the cell phone business has gone to Apple and has not gone to the suppliers. So coming back over here to the automobile industry of the future, Give us a crisper response, not a response, but give us a bit more insight where the money's going to go. What's the bottleneck? It's the user experience, and who's going to own that? Is that going to be the Apples and the Googles, or will it be co-owned? How much of that will Kareem's firm, will they be a co-specialized component of that? Or does all the money go to Apple, Google, and whoever else is in there? Who else can be in there? Can Tesla still be a player, or are they too small in the total scheme of things?
Well, there's a lot of different questions in there, David.
Yes, my mind is muddled, so I'm throwing it all out at once.
I find that unlikely. The chart on the left is purely smartphone industry profits, looking at the actual device vendors. So what we're not looking at here is the profitability of component suppliers within there, and those vary hugely, as you know. So let's since we're in smartphones, let's stay in smartphones for a moment. The Qualcomm, now that Apple has perhaps slowed down from trying to put them out of business, Qualcomm has an enormous amount of market power, and under normal circumstances should be able to make a substantial amount of money. For reasons that we'll get to in just a second, it's challenged to be able to do so. But nonetheless, it's an area where it should have strong co-specialized proprietary assets that it should be able to leverage to market success. At the other extreme, where we're talking about for example, base metals and things like that, pure commodities, but there's a lot of things in between. The display technology, a relatively small number of manufacturers can make that. The camera technology, extraordinarily hard to make. Very few suppliers can make that. So the lesson that I would draw from it is that this chart does not tell you where money is being made underneath here in these areas here. That's a completely separate analysis. What I've focused on here is if you look at the way that the profits flow when one company owns the user experience and can abstract away a lot of what's underneath, then disproportionate amounts of the profits flow to that entity.
Yeah.
We saw exactly this. This is not new. We saw exactly this in the PC industry. If you looked at the PC industry between roughly 1985 and 2000, Microsoft and Intel made all the money, all of it. In any given year, it was difficult to find a PC. The PC industry as a whole was making money. It was that bad. Individual vendors did. Occasionally Dell would make some money, things like that. Okay, so that's the user experience side of it. The next side of it that I wanted to look at was down here, the wireless communication system as an analogy for what I'm calling the advanced driver assistance and advanced active safety systems. The challenge down here is that no one company can own it. And the reason it can't own it is the same reason that you can't own it in the smartphone space, that you need to have standards and protocols. For vehicle-to-vehicle communications to work and vehicle-to-infrastructure communications to work, you've got to have very complicated standards. And the challenge is that once you have standards in the picture, David, as you know, to your cost, then it's extraordinarily difficult to create the kind of appropriability regime that allows you to really make money. The court rulings are complex, untethered from the economics. You've got very poor antitrust analysis that is taking a long time to be resolved, and litigation is common. So the lesson from this is that if we take the same lessons from here to advanced driver assistance and advanced active safety, then it's going to be challenging to make money down at this area. It's going to be interesting to see how it can be done. Okay, strategic questions, and I promise I'm close to done. Hopefully, I haven't run too long. So the first question is there an opportunity for some completely new user experience platform? And I think the answer is yeah, potentially with disruption. This is a big market. This is a very, very big market. And if you look at the way that the world was meant to progress in 2005, 2006, what was supposed to happen is we were going to go from Windows Vista and the Mac OS to Windows CE. That was going to be the world where we basically took a linear evolution. But what Apple recognized was that there was enough of a difference between a mobile platform and a traditional PC platform that you could fundamentally change it. So is it possible that you could do a completely new user experience for vehicles that would be completely different from the evolution of iOS and Android? I think the answer is maybe. But if you're going to do it, you're going to have to really do whatever it takes to disrupt the existing evolution, and we're not seeing that at the moment. The next question is, can that user experience be OEM proprietary? And you brought up, David, the example of Huawei, and I've used that as an example at the moment. So this is the not a particularly good picture of the new Huawei phone, which runs Android. The challenge is there's a hell of a lot of stuff that it doesn't run. And so the question is, can you make a viable phone out of this? And I guess we're going to find out, but I wouldn't want to bet on it. All right, we've gone through sense making. Let's have a look at some scenario narratives. And I've done a couple of these just to sort of play with the idea. And to do that, what I've done here is I've put together this picture of a reasonable ecosystem, which is essentially where you make money, where you invest. So up the top, we have mobility as a service, network services, things like consumer services, data harvest, you make money from advertising, vehicle sales, you actually make money from selling the vehicle. These are all of the ecosystem services that are necessary to make mobility work. And these are all of the existing consumer ecosystem services, everything from media to mail to banking, all of that kind of cool. Then underneath it, we have the vehicle OEM. Underneath that, we have the advanced driver assistance, advanced active safety, and tier one suppliers. These are classic scale advantaged horizontal services and systems. So if we look at Apple in 2021, this is what they're doing. So they're making money with CarPlay through network services that they bolt onto the user interface, and it kind of maybe sometimes works, and it's all good. So this is a reasonable incremental approach for Apple. The concern, if you're anybody else, would be if they do this, which is they take a Foxconn Auto and produce an Apple car. They start to make money through vehicle sales. They put in their own proprietary mobility ecosystem services. They partner to get the advanced driver assistance, the advanced active safety systems that they need. And they compete with the traditional OEMs in that way. But now, because they have a broader ecosystem and they have more places to make money, they become a very challenging competitor for an existing OEM.
And so, John, the other big intangible is the brand. Who's got the brand here on the car? Is Apple the brand, or
Apple has the brand? Yeah.
And you may have read in the newspaper that the reason why the talks with Hyundai and Ford and everybody broke down is because Apple said exactly that.
Yeah.
You're just going to make for us, and it'll be an Apple branded car, and the OEMs thought they had enough power that they could walk away from that.
And I think without the commoditization of the powertrain platform that we talked about earlier, the existing OEMs have a point, because to build IC cars, is hard. It's really hard.
Yeah.
But to build electric powertrains, fundamentally different and much more commoditizable. So I think if Apple decides to do this, there is nothing that will stop them from being able to find several outsourced vendors that will be able to make the car for them, and it'll have the highest quality.
John, we're going to give you a little break. We're not going to let you go, John, even though we know it's late, but it is right at the bottom of the hour, and the class normally takes a 15-minute break. So if this is terribly interesting, and we want to get some questions lined up for you. So do you mind if we take a little break?
No, well, I tell you what, David, give me one more minute. Last slide. So this is Hyundai 2021.
Okay.
This is where they make money. So the question for the House is, what the hell do they do in 2031? What works? And I do not have an answer for you on this, but I think it's the key question. And with that, thank you.
Okay, thank you, John, and thank you for sticking around at the late hour, and we'll come back in about 15 minutes. All right?
Yeah, that'll be terrific. That'll be my pleasure, David.
Thank you.